Welcome to the third video of Mathematics exam series for Victoria, Australia. In this video, we will solve the first 4 questions from a 2020 trial exam 1 paper. Hello Math Champions, I'm Dr. Chen. If you want to improve your math skills and understanding so that you gain confidence, enjoy math more, and get better results, click subscribe and hit the notification button so that you don't miss anything. This is the first part of a 2020 trial exam paper for Mathematics in Victoria, Australia. And this is a technology-free paper. Each question, you may pause the video anytime and try to do it yourself. However, I just explain every question straight away here. Now, the following diagram shows a trapezium bounded by a parabola and the x-axis. All the corners of the trapezium are on the parabola. The coordinates of the turning point of the parabola is 0, 4, and the coordinates of the x-intercepts are -2, 0, and 2, 0. 3 questions are asked. First one, they ask us to write down the equation of the parabola in turning point form. The second one is to express the area of the trapezium in terms of b. And the last question is determine the value of b for maximum area of the trapezium. Based on the given coordinates of its turning point of the parabola, as well as its x-axis intercepts, we have a right trapezium inscribed in this parabola. The first question asks us to write down the equation of the parabola in turning point form. Now, let's recall the parabola's turning point form. Here, the coordinate of the turning point is hk, and a is the dilation factor in y direction. Since the turning point of this parabola is given, which is 0, 4, and after being substituted, we have y equal a times x squared plus 4. In the meantime, we also know the 2 x-intercepts of this parabola. So we just substitute any one of them and then find out the value of the dilation factor a, which is -1. For question 2, in order to express the area of this trapezium, first we need to find out the x coordinates when y coordinate is equal to b. Substituting y by b and then solve this equation for x-intercepts. Hence we have x-intercepts equal plus or minus square root 4 minus b. Now for the right trapezium, the length of its upper base is 2 times square root of 4 minus b. The length of its lower base is just 4 and height is b. Therefore, the area of the trapezium can be expressed in terms of b, which is b times open parenthesis square root of 4 minus b, then plus 2, then close parenthesis. For question 3, in order to find the value of b, which gives the maximum area of the trapezium, we do differentiation dA over dB and then set it to 0. In this way, we find the value of b, which is 32 over 9. Question 2 is a polynomial problem with x to the power of 6 plus 64. As for long division in the first part of question A, for those who still not familiar with it, you may refer to your textbook and practice this skill yourself. Here, I just briefly demonstrate how I do with this long division. After performing the long division, the quotient is x to the power of 4 minus 4x squared plus 16. the remainder is 0. It means x squared plus 4 is a factor of the polynomial px. Based on the result of the long division, px is factorized by x squared plus 4, or in parentheses, times x to the power 4 minus 4x squared plus 16, or in parentheses. For the factor containing x to the power 4, I add and subtract a term of 12x squared to further factorize it, as displayed here. Finally, the product of the three quadratic factors is displayed here. According to the question, we first work out the coordinates of the turning points of these quadratic factors, as shown on the screen. Here we need to use the completing square technique to do the work. Then we define the three vertices are A, B, and C accordingly. Hence, the distance among them can be calculated using the formula of distance between 2 points, and the results show they are equal to 2 square roots of 3, which proves it is an equilateral triangle. Question 3 is a question involves transformation. The original function is y equals 2x cubed minus e to the power of x. After transformation, x prime equals negative y, while y prime equals negative x. According to the definition, we have the simultaneous equations as listed, and finally we find the relationship between variables x and y, which is that x plus y equals 0. Question 4a is an index function, which is a function with variable on the index. To simplify the question, we assume y equals to the e to the power of negative 2x and then solve y. After factorizing 5y squared plus 2y minus 3, we have y equals 3 over 5, or negative 1. Since e to the power of negative 2x is always greater than 0, so the only solution for y is 3 over 5. Hence, we solve x, which is equal to the negative half logarithmic base e number 3 over 5. For question 4b, change base for logarithmic base 3 number 5 to logarithmic base 10, and change logarithmic base 4 number x to base e, as shown on the screen. The right side of the equation, one can be replaced by logarithmic base 10 number 3 over itself. After manipulation and simplification, logarithmic base e number x can be expressed in the required form. For question 4c, we establish two simultaneous equations based on the given coordinates of the 2 points, and then name them equation 1 and equation 2. We proceed to divide equation 2 by equation 1 on both sides, and then work out the constant k, which is equal to 1 over the total value of e squared minus e. Accordingly, a equals e to the power of the total value of e minus 2 over the total value of e minus 1. If you enjoyed this video, please give it a thumbs up and subscribe to help me make more math content like this. I will see you in the next video.